Welcome to Mission 4, Lesson 6. Our student objective today is to use varied protractors to distinguish angle measure from length measurement. Okay, in simple terms, that means we're going to be using protractors to measure angles today. That's what we're doing. So what I'm going to do is I'm going to go through the Tower of Power and use their protractor, so it's the same for you, and we're going to work through measuring angles. Let's take a look. So we're going to use the protractor to measure the angle. So just so we know, on Zern, to get the protractor, we click this show. You have to click the show and then hide. Show and hide, and that'll bring the protractor up. When you are measuring angles, okay, notice they already have it set for you. You don't have to move it anywhere. You just kind of rotate it. You need to set it. Okay, so you notice the dot is right there. This middle dot is set up on the vertex of that angle. So where those two rays meet. It's exactly right there. And I have to line up this bottom line on my bottom line of the angle, that bottom ray. So notice how that's on 0. Okay, it has to be on 0. You cannot do this. You cannot just, okay, there. No, it has to be that solid line has to match up on the 0. So the solid lines match. Now all I'm going to do, I'm looking for the measurement of angle A, B, C. So I'm going to see, follow this line, and what does it cross at? It crosses at the 30. So again, I'm just going to look here. It crosses, if I follow that line, at 30. So angle ABC is 30 degrees. Great job. Thank you, Zern. Keep climbing. Yes, Captain Zern, I will do that. Okay, now we're going to use the protractor to measure the angle again. So I'm going to show it again. Now, the key thing is I cannot just leave it like this because I don't have it lined up correctly. I have to line up this baseline here with that line. That zero line, that bottom line has to be on the line. And just so you know, they do have these little tools up here so you can kind of rotate it by a degree or two. If your movements are too big and it's going too much, you can do it by 1 or by 5. 5 moves it like that, right? But okay, I want it to land exactly on the 0, just like this. Now all I'm going to do, because I can see there's my 0 line, and then, okay, it's on the vertex here. I'm just going to follow this line up and see where it crosses. And where does it cross? What number is that? That is 120. 120 degrees. You got it. I did get it, didn't I? With all your guys' help. Thank you. I appreciate it. Okay, use a protractor to measure the angle. Same thing. We're going to show it. Okay. Now, this is where it gets a little trickier because, again, I need to line up this line on the 0. Okay. So notice I can't do this. I have to put this line, that 0 line, boom, so it lays flat right here on this bottom ray of this angle. Okay. And then I'm doing the same thing, and I'm following this line up to see where it crosses on the protractor. But this is where it gets a little tricky because now you can see I have 2 options. It says 140, and it also says 40. So I need to ask myself, is this angle, DEF, is it 140 degrees or is it 40 degrees? Now, first of all, they put both on there because this angle is facing the other way. So you can use a protractor like this to measure an angle facing any direction. Okay, so that's why it has numbers on both sides. In this case, it's going to the left. Now, when I look at it, okay, so my choices are 140 or 40. Well, how do I know which to use? I look at the angle, and I think, well, is this angle a DEF, an acute angle, or is it an obtuse angle? Well, I know it's an acute angle because it's smaller than 90 degrees, right? Look at it. Its mouth is more closed. It's not 90 degrees at perfect L. Obtuse angle would make it bigger, but this is an acute angle. It's smaller than 90. So if I know it's smaller than 90, because it's an acute angle, is it going to be 140 degrees or 40 degrees? It's going to be 40 degrees because that's the one that's less than 90. I know a 140 degree angle is going to be larger than a right angle. Okay, excellent. All right, we're going to do the same thing now. Now we're measuring angle ABC. So again, this is a little one. Okay, so again, I have to line. So I'm getting that 0 line lined up on that AB line right here. And then what I'm going to do is I'm just going to follow this line out. And again, I have two choices. Is it 140 or is it 40? Well, again, if I look at this angle, if I hide it, is that angle acute or obtuse? It's acute because it's smaller than 90 degrees. Or 90-degree angle would be a perfect L-shaped. But in this case, it's an acute angle because it's smaller than that. So if my choices again are 140 or 40, well, which is it going to be? It's going to be the one that's less than 90 degrees again. It's going to be the 40-degree one because 140 is an obtuse angle. Great job. Thank you, Zern. I love it when it compliments me. Okay. Now, this last one says, what do you notice about the measurements of these angles? So it says angle DEF is 40 degrees and angle ABC is 40 degrees. Okay. So, but does it look like other side lengths the same? No. The side lengths are different. But angle measurements are the same. And that's what you can realize too. This angle measurement is not determined by the length of the sides. So even here, smaller sides, longer sides, but the angle can still be the same once we measure it out. Good work. I earned it. I did it. I'm so proud of myself. All right. So just practicing using those protractors today, getting used to it, getting it set up and following it along. Okay. Good luck to you. And if you need any help, feel free to ask me or your teacher.